Chapter 1, Functions, Limit and Continuity. So we will cover with the topic of continuity, which is continuity is a function of f(x) to be continuous at x is equal to a. So if limit f(x) when x approach to a is equal to fa, so we call this function is continuous. So we need to have 3 steps in order to fulfill the continuity function. So the first one, we need to define our fa is defined. That is a in the domain of f. Then the second step, you need to identify your limit of fx when x approach to a must be exist. It means that if you have limit of fx when x approach to a positive must be equal to limit of fx when x approach to a negative. Then the third step is step number 1 must be equal to step number 2, which is limit of fx when x approach to a must be equal to fa. So now let we look at the example of continuity. Okay, so example 7 here. Find the value of k using the definition of limit. So we are given here fx with 3 different functions. This is our first function. Then we have second function fx equal to kx square minus 4. Then the third one is fx is equal to 16 minus 5x cubed. Okay, so let we draw first our number line for these 3 different functions. So in order to draw the function, we need to know the interval for every single function. So the first one, we have a function of x less than negative 2 here. And the second function is the function must be in the interval of negative 2 and 2. And the third one is x must be greater than or equal to 2. So the first one, for limit of x less than 2 is belongs to the function of reciprocal, which is x power of 4 minus 16 over x plus 2. And the second one is in between negative 2 and 2. So this one include for negative 2 but not include at 2. And before this is not include, which is what? Okay, sorry, this is black and this is what? Move to the left. And then the last function is starting from 2 to the right, which is the function is 16 minus 5x cubed over x. So the first step in order to identify whether our function is continuous or not, we need to know whether limit of fx is exist or not. Okay, so let we solve for limit of fx when x approach to negative 2. So the first function, we want to find the value of k such that limit of fx when x approach to negative 2 exists. So when have the word exist here, it mean both side limit of fx from negative, from right hand side and left hand side is equal. Okay, so let we solve one by one. So limit of fx when x approach to negative 2 negative must be equal to the limit of fx when x approach to negative 2 positive, because the question said that limit of fx when x approach to negative 2 exists here. So limit of fx when x approach to negative 2 negative, we look at our interval from the interval from the number line negative 2 here. Negative 2 negative means negative root at left hand side. So we substitute the value of the interval at our left hand side, which is x power of 4 minus 16 over x plus 2. So when we substitute the function with negative 2 here into the limit, we will get 0 over 0. So we cannot solve by left our function with 0 over 0. What we need to do is we need to factorize the function. Okay, so we factorize first our polynomial function at our numerator, which is x power of 4 minus 16. When we factorize, we will get x squared minus 4 times x squared plus 4 over x plus 2. So from here, we factorize again for one function of x squared minus 4. We make our second factorization. We will get x minus 2 multiply with x plus 2 multiply with x squared plus 4 over x plus 2. So from here, we can cancel our numerator and denominator, which have the same value, which is x plus 2 at our numerator and also x plus 2 at our denominator. So what left is a function of x minus 2 times with x squared plus 4, and don't forget to write down the limit of x approach to negative to negative. So let we look at our function now. Next, from here, okay, after we factorize our function, so we can substitute now our limit with negative 2. So when we substitute our x with negative 2, we will get limit of fx when x approach to negative 2 negative is equal to negative 32. Okay, this is solved for our left hand side. Okay, let me solve for the right hand side for x approach to negative 2. So for right hand side, we will get limit of fx when x approach to negative 2 positive is 2 from right hand side. So from this number line, from right hand side is kx squared minus 4. So for kx squared minus 4, we substitute the value of x with negative 2 because our x approach to negative 2, then we will get 4k minus 4. Since these two approach from 2 negative and 2 negative and 2 positive is exist, which is state at the question, so our left hand side and our right hand side must be equal. So we write down here our last answer at our right hand side, which is 4k minus 4 is equal to our right hand side, our left hand side and right hand side, we make it equal. Then we solve for the value of k, which is we will get the value of k is equal to negative 7. Then we want to solve for question B using the value of k in A. So determine the function is continuous at x is equal to 2. So for x is equal to 2, we look at number 2 here. Okay, we look at number 2. Then we can see here number 2 and black dotted, which is the function involved is 16 minus 5x cubed over x. So we take this function, which is 16 minus 5x cubed over x, by substitute the value of k is 16. Okay, so we just find our f2 here. So we substitute the value of x equal to 2 into the function of 16 minus 5x cubed over x here. So we will get our f2 is equal to negative 12. Okay, so when we substitute of f2, we will solve and we get f2 is equal to negative 12. And then we look at our, in order to identify whether our f2 is exists and not, we need to use proof whether the left hand side and right hand side from K from, this is our 2 function. Okay, this is from our left hand side. So this is a function, left hand side means 2 negative, and then this is from right hand side of 2, which is 2 positive. Okay, so in order to find the continuity at x equal to 2 here, so we need to use 3 steps that I have mentioned previously. So the first step, we have already find our f2 is equal to -12. So this is defined. So since our first step is defined, we move to our second step. So for our second step, we find our limit of fx when x approach to 2 negative first. So when our x approach to 2 negative, we solve and we will get our x is equal to our limit of fx when x approach to 2 negative is equal to negative 32. So why we take this function? Because if we look at this table, okay, kx square minus 4 is at our left hand side. So we take the function of kx square minus 4 as our x approach to 2 negative. So when we substitute, we will get the value is equal to negative 32. And then we solve for the fx of x approach to 2 positive. So from our number line, from 2 positive is the function of 60 minus 5x cubed over x. So when we substitute the value of x is equal to 2 here, we will get the value is equal to negative 12. So if we look here, the function of fx when x approach to 2 negative not equal to limit of fx when x approach to 2 positive. So we conclude that our limit of fx when x approach to 2 does not exist because it have the different value between left and right hand side is not equal. So when both left hand side and right hand side is not equal, so we conclude the limit is does not exist. Okay. Hence, since our first step, which is f2, even though f2 is defined by our second step does not exist, so the limit of f2 fx when x approach to 2 does not equal to our define also. So therefore, fx is not continuous at x is equal to 2. Okay, we look at example 18 here. So for example 18, first of all, when we want to solve the question, we draw first our number line. So the first number line is x less than 0 without equal interval. So less than 0 here to the left. Then from 0 to the right. Okay, to x here. Then from 2 to the right. Okay, so the interval, the first interval is hx equal to x less than 0. Then the second interval is from 0 to 2 is the function of hx equal to 2x squared, and the third function is negative 2x plus k when x greater than 2. So the first one, we want to find whether our hx is continuous or not at x is equal to 0. So the first step, we need to define our h0 first. So how to define our h0? The first step is we make our h0. We find our h0. So we look at our table, which one is 0 here. So 0 and include, move upwards and until we find include here. So the function is 2x squared. So we replace the value of x with 0 because we want to find h0. So we will get 0 here. And then the second step, we need to look our h x equal to 0 from our left hand side, which is 0 negative, and from our right hand side, which is 0 positive here. Okay, so we look at these timelines and we make a solution for each one. Okay, so we solve for hx when x approach to 0 negative first. So for hx when x approach to 0 negative, the function is x. So we replace with x here, then we will get 0 here. And then for hx, for x approach to 0 positive, the function is equal to 2x squared. So we replace the value of x with 0, then we will get the same value for left hand side is equal to our right hand side. Then we conclude that limit of hx when x approach to 0 is equal to 0. Since our limit of hx when x approach to 0 is equal to our first step h0, which is equal to 0, therefore we conclude that our hx is continuous at x equal to 0. Okay, then the second question, we want to find the value of k such that hx is continuous at x is equal to 2. So let we look at our diagram again. Okay, now we want to solve for x approach to 2. So we look at our x approach to 2. So it's mentioned that this function is continuous. So when it is continuous, mean our first and second step must be equal. So let we find for the first step, which is we need to find h2 because the question said that limit is exist at x2. So we replace the value of x with 2 now. Okay, so from this number line, you move upwards until you see the black dotted. So if the black dotted, the function involved is 2x squared. So we replace the value of x with 2, then we will get 8 here. Okay, then we take our second step. Okay, we do our second step, which is our second step, we need to find the limit of hx from left hand side and from our right hand side. So limit of hx when x approach to 2 negative. Okay, we look at here, this means 2 negative at our left hand side, and the function is 2x squared, and we substitute the value of x which 2, and we will get 8 here. And then limit of hx when x approach to 2 positive is means from right hand side. So we substitute the value of limit x approach to 2 positive from the right is negative 2x plus k. So we substitute the value of x with 2 now, then we solve, we will get negative 4 plus k. So we make both right and left hand side must be equal, and we solve for the value of k, and we will get the value of k is equal to 12. Okay, so we have tutorial here. You can do by your own first. Later on we will discuss